All right. So, welcome back, everybody. Welcome back. I got an echo going on. Welcome back. I got an echo going on. Welcome back. I got an echo going on. Why is that mute? There we go. Sorry about that. Okay. So last month we had talked about what was then ML API, and about 3 days later, Unity went ahead and launched their gaming services um, initiative, I guess you'd call it. And they put a bunch of their services out there that are, um, most of them are currently still in beta, but they've kind of conglomerated them all into um, one service or a bunch of services. And we'll be talking about, they renamed ML API to now it'll be NetCode for game objects. They also have NetCode for dots, which is their data-oriented tech stack. It's the similar name, but they are completely different frameworks for this. So we'll be going over the NetCode. We'll also dip in a little bit into their relay service, which is a peer-to-peer service that will handle like getting through NAT services and stuff like that. They also have a lobby system that's also in beta that is pretty easy to use. We'll go through a little bit of how to set that up as well. Some of the other services that they've released, Vivox is a in-game voice chat service that they purchased a few years back. A lot of big name games use it for their in-game voice. Multiplay is another service that they bought. Is for hosting dedicated servers. That is not quite public yet. Apparently that is soon, as is their matchmaker, which is going to tie into multiplay. If you were with us a few months ago, I talked about how PlayFab does their matchmaking and server allocation, things like that. They've also bundled they have Cloud Code, which is, I believe, also their Cloud Build, I think is part of that as well. There's Cloud Save, the economy, which is the in-game items and currencies and whatnot. Authentication, we will actually be using a little bit of this because the relay service actually ties into their authentication service here. We have on this side here, like the analytics side, the remote config, their cloud content delivery. All this stuff has been out for a while, but they are now just bundling it into its own little tab here. There's also the in-app purchases, in-app ads, I believe is part of the monetize here. But we are here to talk about upgrading from ML API to NetCode for game objects. And they did break some stuff here from what we did last month, but it is not entirely unreasonable here. So the first thing you'll need to do actually is go into your package manager, and if you've had ML API installed before, you'll just need to uninstall it from the package manager. And in here, you'll click the little plus symbol here, and you'll go to add package by name. And I believe it is unity.netcode.gameobjects. Game object. believe it is game objects. And you'll get NetCode for game objects here. You'll also get a couple of samples here. And if you did extensive work back in the ML API days with like the network transform, they've kind of changed how that works. They've made that more of they made it totally server authoritative instead of client authoritative. So before, when you had your network transform, you could move the player on your client, and then it would tell the host or the server that you moved, and then it would replicate that out to the rest of the clients. The way it is now, that it is now server authoritative, so you need to tell the server that you've moved. So you'll basically use the remote procedure call to send a input to the server, then the server will move, and then it replicates itself out. We'll look over that a little bit here because I had to change that up with the little demo we made last month. But here in the samples, there is a client network transform that will work exactly like the old network transform does. You'll also want to install the lobby and the relay, I think, is this is here, but it's also called something weird. It is what is it called? NetCode adapter for UTP is what you need to type in the name here. So the other big change that they did was they changed the namespace. So here in our code, wherever we had using ML API, all of these have gotten consolidated into unity.net code. The other things that they've changed is a bit how network variables work. So before, when we had a network variable for like a string or an int or something, they had just a class that was network variable int or network variable string. And now you just have to, let's see, do I have a sample here? A little bit here. So now instead of using this is a network list, but same is still here. You just have to put it in the angle brackets here is what your type is. I guess since we're here, network variables can't use strings. So what they've done is in this unity.collections, they've given us a unmanaged string class here for a fixed string 32 bytes. There's a number of these. We can actually see. There's 32, I think there's 64 and 128 string lengths here in this unity.collections. The other things that changed is the network variable settings. This got removed completely. So whereas before you could set who could read and who could write to network variables, now it's just straight up only the server can write to a network variable and the clients just have read permissions. So you can't even set these anymore. The other thing, I don't know if I was actually using Scenemanager, but the Scenemanager and the Spawn Manager are now just inside of the Network Manager singleton. Here, they were their own class, so now you don't have to worry about those anymore. It is just network manager .singleton .scene manager is how you would go about switching scenes. I think I was actually doing here. I didn't. Did we use? I think I actually did. So another thing that changed was network start was previously called once I think the first time when a object gets instantiated on the network. That is now called on network spawn. I think the player might be. Maybe we use it. Yeah, I use it here. So the on network spawn also needs to be overridden here instead of just using network start. So I guess technically I could use base dot. Nope, that's not what I do. That's why I don't do live coding. Base dot on network start. There we go. Okay. The other big thing is on our custom message handler. We were using this to just send our unnamed messages and also register named messages. For this, it's also just been consolidated down into Unity.NetCode. But the custom messaging manager is also in the network manager singleton as well. And instead of getting passed in a pooled network reader, they've gotten rid of that. And this is, I believe, just a fast buffer reader. And also, there's a fast buffer writer as well. So you can see here, before we just had to get a network reader, give it our stream, write our string to it. Now we are just taking our stream, our fast buffer, and there's just a read value safe out of it. And this will automatically just output our string to it that we just print. So yeah, this will actually work with any type that you actually give it. For the writer, it's much the same way, except for the writer, you do have to get a new fast buffer writer, but it'll just write whatever you want to it. It's not a big change, but it is something you need to look out for. And I think for update, that's really about it. I don't think there's anything else that actually changed. I guess for the network variables, if you're making your own, this did change a little bit here. So instead of being network serialized, it is a network serialized with a generic type, and this also uses the reader writer instead of no, it just has that as the type. So the instead of using the serializer dot serialize that we used up top, it's just a serialized value and a reference to said value. You'll also, I think this is actually needed as well. I haven't actually tested this, but you'll need to have equals here from Equatable to tell the NetCode that your variable has actually changed. So if it hasn't changed, it will not flag itself dirty and update the other clients for it. Okay. And yeah, that's it for the big changes. Okay. So let's talk about the relay service now. Oop. So the relay service is, like I said, is their peer-to-peer service that its main use case is getting through NAT punch through for peer-to-peer connections for players. It also will integrate into the lobby system that we'll get to in just a second. Here. There we go. So this is a nice little diagram here on how the actual service is set up as. So you'll have one player as your host player. That'll basically be like your server. We're using it as a server here. It's going to connect to the relay server. All of your connecting players will also connect to this relay server. And then from here, the relay server, this will basically relaying the packets from the relay server to the host player and back and forth that way. So this way, like your connecting players don't need my IP address for me to host a game on it. There are some, I guess we could get into some of the prices here. There are some limitations here. There is a maximum of 10 concurrent players per match. So you're not going to be having, huge 16-player peer-to-peer matches. If you're doing anything more than this, you'll need to have some dedicated servers set up, which arguably you should probably do that anyways for 10 players. That's a lot for a single home connection to handle. For now, I think there are only 4 servers available right now. Asia, East Europe, East Europe, West US, and Central US. Once this gets out of beta, they will be opening up more locations. Okay, and do need to actually look up some prices here. This is important because these services are not completely free. There is a free tier. The free tier is pretty good for, especially while you're developing it's definitely more than you'll need. So here for our relay, the free tier is for 50 concurrent users. The standard tier is from 50 to 200 concurrent users. And the premium tier is 200 plus concurrent users. Then here's the pricing for it as well. There is a lobby here. So the lobby is free for the first 10 gigabytes of bandwidth that you use per month. And then beyond that, it is 9 cents per gigabyte in the US, 16 gigs in Asia and Australia. So yeah, just something to keep in mind. Very few of these relay services are going to be completely free for all your players. So once you get into production, depending on your success levels, 50 CCU, you might never even see that. Okay. So basically, setting up the relay as a host, you can either do this through the NetCode framework, or you can actually do it through their Unity transport layer. The transport package is a lower level, so you're dealing like directly with like the network driver and listening to and binding ports and whatnot. Most people won't have to worry about doing that. The other thing that you will need to do is go to your dashboard in Unity, which is, I'll open up here. Here. So if you've never been to your Unity dashboard, this is where all the various services actually live for your project. And this is, if you're keeping track of all your monetizations, your users, and whatnot, is all going to be here. So this will have all of your projects is listed here individually. And for us, we'll go down to multiplayer, and you need to make sure that your relay is turned on and active here. When you turn on relay, it will also turn on lobby as well. So you don't have to do them both separately. You can use them independently of each other, but for now in the beta, they're linking the two. So you turn one on, you will turn them both on. Okay, so this is our client. We'll take a look at the server here first. Once it decides to come up. Okay. So in Connection Manager. Okay. So there's going to be a bunch of services here that we'll be actually using here. So there's the relay service, the models for like player classes and whatnot will be here. We'll do the authentication. I'll show that here in a second. Actually, we can pop over to Unity here to see that and our lobbies, services models and stuff here. So the first thing that we are actually doing here is initializing our services and also authenticating here. This is not in here, so this will be in our authentication here. Okay, so this is how you actually just authenticate anonymously. You just call your authentication service .instance.signin anonymously async. And what this does is this will communicate with the Unity service here in our project settings. Here in the project settings, you'll see some of the services here you can get set up. Here for authentication, you can, I don't know if you can actually see that, but there are different providers that you can set up for Apple, Facebook, Google, and Steam. So if you were set up for Steam authentication, you could add your app ID and your key, and then you can go through and there is a Authenticate with Steam service here, which I think we can just look at some of this. Authentication service .instance . So here we can link with any of these external services, or we can sign in with Apple, Facebook, Google. We can sign in with an external token if you're using some other weird thing to install OAuth or whatever. And yeah, signing with Steam here. But we're just signing it out anonymously. I believe this is using like a system GUID or something. And this actually gets saved to your registry for the project. And so when you link like your Steam or Facebook or whatever account to this, you don't have to keep signing in. It'll save your authentication token to the registry and then pull that back up whenever you need to sign it again. So yeah, once this actually goes through or throws an exception or whatnot, then our connection manager here, once this gets signed in, we're going to run a coroutine here to start our host. Now for the relay server, to get a join code, you just need to give it your max connections. So however many people you want to join your match, this will, you need to give it to that. So I'm just using 10 here since that is the max of the relay server. We're just using that. And so that's just going to wait until that task is completed. Most of these are using tasks on the API side, which allows us to do cool things like this. So if you've never seen a return value like this is something you can do with tasks. And this is going to, this task here, I think we can look that up here. It returns a IP address, a port, the allocation ID in bytes, the connection data as a byte array, our key, and our join code. So using tasks in this way lets us do like multiple return types. And our join code is what we're actually going to be using to create our lobby with. So once this gets done here, then we are going to, we get our join code for our relay. So you could technically use this without creating a lobby. If you just want to type in this join code in a group chat or something, you can just join straight up for have the users type in this join code, and then they'll just automatically connect to you. So here we are going to start creating our lobby with this join code, but we'll also go ahead and start our server. So we're just starting our server with the address and the port that the relay server gave us here. So we're using the Unity transport here, and we're setting the server data for all the server data that we got here. And then you just start your server like normal. This task is the actual allocate server allocation and join code task. This is just pulled straight from the docs, and I didn't actually change anything here, but it is just going to create an allocation with our max connections and our region. And I think default region is East US, I believe. And then this will create our join code here. You just pass in your allocation ID. And then it returns our IP address, port, and whatnot here. So creating the lobby here. So our lobby has a number of options here. I think the docs for lobby. Here we go. So our lobbies can be public or private, and that just dictates how you can actually join a lobby, whether it's discoverable through a search or joinable through a lobby code or a lobby ID. So just like with the relay code, you can type in a lobby code and just join directly to it. There's also quick join, which is what I'll be showing you. And this is just a quick match. So it will grab whatever lobbies are open and then pick one at random. We're only going to have one lobby here, and it's just going to join it automatically. There, you can also give it some options, which I don't know if our options, it does say here somewhere. But basically, when you create a lobby, you need to give it a name, whether it's public or private, the lobby size, so you'll give it a max number of players in your lobby. So like I said before, your lobby does not have to work with the relay service. So there really is no maximum lobby size you can have. If you want to do this with your, battle royale or whatever, you can have 100 people in your lobby, and that'll work fine with your dedicated servers. You also need to give it some initial lobby data. So what we're going to be doing is we're going to give our lobby data the relay code for our relay service. So that's going to be how the clients will connect to your actual relay, your relay server here. You can also do things like game modes, map IDs. If you wanted to do like skill rankings for ladder matches and whatnot, you can put that in there as well. So you can do some rudimentary matchmaking here if you had like skill levels for this match. Like this is going to be gold level or platinum level or whatever. You could do that with this. There's also your host player data. Since our host is a server, I'm not actually using host player data. But this would also be a place where you would put in like player names. You can also put in characters that they are selecting before they join a lobby. That'd be a good place for that as well. Your lobbies will only remain active for 30 seconds if it doesn't receive a heartbeat request from the host, keeping it alive. So if your host disconnects or for whatever reason stops communicating, your lobby will actually inactivate itself until 3 or 5 minutes. Then it'll actually delete itself. But there is a rate limit for heartbeats as well, so you can't just DDoS the lobby servers. It's a limit of 5 per 30 seconds. I think mine is heart beating every 15 seconds, I believe. We'll check that out. So let's get back to our code. So here, we're just creating some new lobby options here. And here our data is a dictionary with a string and a data object here. The data object also has some visibility options here. So we've got here we've got public, which is available to people who haven't joined the lobby yet. Members, which is available once someone has joined the lobby, and private, which I believe is the host only. The other thing here is the indexes here. You have a limit of how many options here you can add. So there's 5 strings and 5 numbers. I believe these are integers, I believe. So for our relay code, we're just using that as string 1 for here. So we could also have your map type, your mode type. You can have max players or players per team can be in here as well. And then we just create a lobby. And then we create a lobby. We give it our name, our max players, and our options. And that's basically it. Once this gets done, our lobby is created. And then I start a coroutine that will heartbeat the lobby every 15 seconds. And for the heartbeat, it is just there's a lobbies singleton here, which is just a instance dot heartbeat ping, and you give it the lobby ID. And also, once the application is quit, I'll delete the lobby because I don't want the lobby hanging out there for longer than it needs to be. Now for the client, it's really about the same. Here. So what I'm doing here, this is the old code here. So here is a quick join. So when you are looking for a lobby, you have a query filter here. So this will let you limit the number of lobbies that you are looking for. And I don't think there's a limit to it, the number of queries you can have, but you can totally stack these up. So right now we are looking for any of them with a max player that is greater than or equal to 10. And there's a bunch of these field options as well. By default, you can look for the max players, available slots, so you're not looking for matches that are full already. You can sort by name or their created date or the last date they were updated. And again, you can also search for any of these string names or the number indexes as well. You can also here, I didn't actually put any player data here, but here is where you could enter in any of your other player data that you wanted here. And so like our player data. Player data also has visibility options as well. And it works much like the lobby data. So it is just a dictionary of a string key with the player data object. So you can put in whatever you want to here. This could be display name, and then give it a visibility of public, value of whatever your display name is. And then also, if you are wanted to update your player information after you've joined the lobby, then you would just use this update player async information here. The same for the lobby data as well. If you wanted to change any of that data, say you guys picked a different map or whatever, you could update the lobby data through update lobby async as well. It's our server. Yeah. So yeah, let's take a look. Server. Okay. Ran out of time to put fancy graphics on the screen, but we've got our anonymous sign-in is connected. We've got some server connection data, our allocation ID. This is our join code for the relay join code, and we've created a lobby. I should have printed out. There it is. So this is our lobby ID, this little random blob here, and our lobby code is right here as well. And I'm heart beating here, so our lobby stays alive. And then in our client, here, and when I start client here, this is going to also authenticate anonymously, and then it will find the lobby and then join its relay server here. Unless it doesn't find any lobbies. Come on. There we go. Link. So yeah, we've got our, we joined our lobby. We get our connection data, our allocation ID, and then we start our client and we are connected. And my player code here is a bit janky, but it works. Yeah, we can see. Do it this way. Okay. For some reason, it is always looking back straight up when I stop moving. I haven't quite figured that out yet. And you can see some sliding going on. That is just lag from hitting the relay server and back again. You could do a bit more work with some client-side prediction and whatnot. But this works pretty well for just basically using the standard, our standard third-person controller here. That. There is a couple of bugs here with the relay service, with sending too many packets or something. I'm not sure what that is, but it doesn't seem to be affecting much here. So in our layer, not this one, armature here. So what we ended up doing here is first we had to, just like before, we had to make it a network behavior. And the only thing I've changed is down in our movement here. I just have a server RPC that I am sending a vector3 to, which is ultimately the direction that our character is moving in. So here is our normal, actually I think I did change this up a little bit, but here is our target direction, which is getting from our input system. We're giving a speed, time.delta time, and I added in, this was in our jump code. So this is our vertical velocity. So whenever we press jump, this vertical velocity becomes 1. And then I'm giving it, multiplying that by times.delta time. I don't need to do that twice. That might be why I'm messing something up here. But I'm just getting that vector3. I am moving our controller locally here, which actually I don't think actually does anything because we are in have a network transform on it, but I kept it there. So we're taking this, we are sending it to our server, and then in server, third person controller, I commented out the move function here just because on the server there is no input system. So there's no input to actually control any of this. And then all I'm doing here in the move player script is we are rotating. Yeah, we're just basically rotating the player and then calling the character controller to move it around. This is probably where my bug is happening, that it's moving back up to the top whenever I let go. But anyways, we'll figure that out later. So yeah, that's basically it for the relay and lobby system. It's a lot easier than PlayFabs was, but not quite as fully featured either. But most of that will change with time, especially once these things get out of beta. So yeah, if anybody has any questions or anything like that, just leave it in the description there, or hit us up on Discord or on our Telegram, and we will we'll get back to you on that. I will end up, this will be up on YouTube as well, and I should be able to get both these projects up on GitHub later tonight. I don't think there's anything weird in here that I have to strip out. But yeah, didn't do too bad, about 40-something minutes. Cool. All right, so I guess thank everybody for watching, and we will see you guys next time.